Hello people, today I would like to present our hackathon project. So we are participating in EDAI Hack 2.0 hackathon. So and we selected the problem statement number 8, which is industrial knowledge intelligence unified asset and operations brain. So in short, this is a platform which connects engineering manuals, worklogs, inspection reports, and safety regulations into a single queryable intelligence system. So it's an agentic graph rack platform. So coming to the technical details of it, so for the backend of vector storage, vector DB, we used ChromaDB, and while building the knowledge graph, we used network X and built the knowledge graph based on the documents we ingest. So we'd like to give the complete overview of how our architecture is. So like all this is present, all the PPT is present in the GitHub repo. So this is a basic architecture of our data flow. So which is ingest the data. So you need to upload whatever documents you have in the ingest phase, and internally after ingestion. So internally itself will extract the keywords from the database you uploads, and will build a knowledge graph out of it, and store them in the ChromaDB and build a network knowledge graph using network X. And we have RAG engines and all, like this is something like a copilot engine where you can chat with the documents you just ingested, and later it's an UI. So we also give put some guardrails to it. So we have evaluated our RAG application with few of the sample data. So this is how we saw through it. Like the RAG source attribution is which is close to 93.3%. So which shows that it actually uh, takes the correct documents while matching the queries with the answers. And also regarding the graph completeness, so we matched up with 83.3%. So which says that it successfully maps the connection between the failure modes and the personnel we provide. And like sorry, this is on free tire in the PPT, so I think that's why it's blocking this. So if you want to have access to this PPT, so I'm pushing this in the GitHub repo. So let's just run the web RAG application now. So the first thing is first, so you need to check your environment. You need to install all the required libraries first. So you can just use it in a single clickable command. So if you just run this, it will install all the required dependencies. So and later, after installing all these dependencies, you just needs to check whether you are the environment you set up is actually working or not. So for this, I'm just using a free tier of Hugging Face model. So you can upgrade it by using the OpenAI tool. So uh, be sure to run Python check env.py before running any of our code. So what it does is internally, so we will run our environment checker. So this is a built-in safety script that verifies all dependencies, inspects API connectivity to our LLM provider. So since I'm using Hugging Face, so this tests the DeepSeek V3 compatibility across Network X and radio versions. As you can see, all checks returned OK, indicating a stable system environment. So after checking the environment, all you need to do is uh, I have already put the sample data here. So using this sample data, try to run this evaluate.py, because before ingesting your data, you just need to confirm whether all the pipeline is working or not. So just try to try this command like Python evaluate.py. So what it does is next we execute our main evaluation pipeline. So in this step, our document processor classifies and chunks our planned documents. The entity extractor uses regex and LLM prompting to extract tags and relationships. So and our database index this data. So and data will go into this knowledge base and all. So this is all for the Python evaluate.py. So now for the final step in our case, so we need to run our app. So to start our app, so we need to click on Python app.py. So this will start an Gradio server, which is for me. I just use the localhost port of 7860. So the backend starts the development server at localhost port 7860. So let's just open this port. So this is localhost port. So here you can just ingest your files or whatever JSON files or MD files you can just ingest it, and later it will try to build a knowledge base and a vector database. So for the first time it will take quite a bit of time. So for now, since I just load the sample data, so which is pump db or something. So you can see here, so it will just show like what it's doing here. It's building the graph here. It's mapping the entity relationships, and it is extracting the keywords from from these documents using regex. So and later you can just come over here and ask the expert copilot. So here I just ask what pages has pump pv 101 experience introduction, so on. So this is an answer coming from the document. See here, it is also listing out the document sources. So these sources are already ingested in the sample data. So you can just see like it's closely mapping towards the answer and all. So this is our use case. So we can also check the evaluation metrics here and all. So for this you need to when you click on the load evaluation metrics, so it will just try to give an breakdown on the sample data we have at present. So these can be changed by uploading your own data graph here. So you can, for the same with the visualized knowledge graph. So this is how the knowledge graph looks like. So since there are total 39 nodes and there are 33 equipment files it found, similar with the maintenance intelligence. So based on the report, like it will analyze like how close it is mapping with, and is there any issue with the current analysis and all. So it will provide the root cause for it, and with the health assessment and stuff. So this is our use case. Hope you like it. Like you can just check the GitHub repo. We are showing this, and thank you for your time. And also like before wrapping up, I just maybe I may have confused you in the features of the RAG application. I'll just quickly wrap up what each thing was in the repo. So the first is the dashboard. So here like it's an once the documents are loaded, the screen shows our system statistics, including total chunks, indexed, and graph elements. And coming to the data ingestion, so under ingestion, like operators can drag and drop any technical manual work order or SOP. The backend passes the layout, extracts semantic chunks, and automatically classifies the document type. So the RAG engine knows how to prioritize. And later the expert copilot. So this is an context enriched RAG chat. So when we ask about any question, so it performs the semantic vector search and queries our vector database and knowledge graph. So that's how it gives us an answer. So and when it comes to this maintenance intelligence, so it just shows this root cause analysis and equipment health assessment and the maintenance prioritization. Because it automates fault investigation, so it synthesizes past work orders and creates structured 5 why root cause analysis while calculating all overall equipment health cost and weekly maintenance list. So that is all. So I would like to thank you once more. Like hope you like it, and please do visit our code. And I think we can just make this open source too. So if you have any updates we can add, or any concerns regarding code, please do reach us out, and we'll try our best to make this in a high-end working setting. Yeah, thank you.